chapter 10 instance 5. So referring to the map, the distance between the point P and B is 3.2 cm. Okay, this distance is we so-called is horizontal distance. Okay, and then so that means PB is 3.2 cm. Let's say PB here. Okay, it's 3.2 cm. That is the measured distance. So we need to find the actual distance. And suppose PB is represent a straight road. Find the inclination of PB. So for part A, we need to find the vertical distance of PB. Okay, that means for B is in a contour line, it should be 800 meters. And then for P, it should be 300 meters. So which is equal to 500 meters. And then the horizontal distance of PB, it should be the measured distance is 3.2 cm. And pay attention on the scale. 1 to 90,000, that means is for 1 cm equal to 90,000 cm. So now if the horizontal distance is 3.2, then the actual distance is, you need to multiply by 90,000 cm, which is equal to 288,000. So we need to change in the same units. So that means it's 2,880 meters. So if I try to draw a right angle triangle, if this is P and B, the vertical distance is 500 meters and the horizontal distance is 2,880 meters. Then the gradient of PB is 500 over 2,880, and the question is asking us the inclination. So that means tangent theta is equal to 500 over 2,880. So the theta will equal to is approximately 9.849 degree. So according to the requirement is nearest degree. So which is theta is the inclination is around 10 degree is correct to nearest degree. And for part B, the actual length of the road, okay, that means this one, the actual length of a road, that means it's hypotenuse of PB. So and the answer need to correct to nearest 100 meters. So it's easy because it is a right angle triangle, so we can use Pythagoras theorem. So PB square, which is equal to 500 square plus 2,880 square, which is Pythagoras theorem. Okay, and after the calculation, you know that PB is equal to 2,923, which is approximately to 2,900, which is correct to nearest 100 meter. Okay, that's the end of instance 5. So in the map, you need to find out the first one is the actual vertical distance and the actual horizontal distance, and then you can find the gradient or the inclination. And for actual length of PB, it can you use Pythagoras theorem. Okay, and I have one more extra example as the class practice 10.1, which is from class practice 10.1, so that you will know it more. Referring to the map on the right, the length of PQ is 2 cm. So this is the horizontal length is 2 cm. So you need to pay attention on the scale. And if PQ represent a straight row, find the gradient, okay, of PQ. So we need to free some issue is, first of all, is the vertical distance of PQ, which should be for P is 175 meters and minus Q is 125. Okay, after that, you know that the vertical distance is 15 meters and the actual horizontal distance of PQ is, so is 2 cm multiply 40,000, so which is 80,000 cm. So we need to change to the same unit, so from cm to meters, that is 800 meters. So I try to draw a right angle triangle for you. So it's from Q to P. So the horizontal distance is 50 and the vertical distance is 800. So the gradient of QP is, the vertical distance is 50 and the horizontal distance is 800. And after simplification, it's 1/16. So the answer, the format of the answer we need is a ratio format, 1 to n. So it should be, so the gradient of QP is 1/16, and that's the end of this